So today we're going to look at graphing transformations again. Now, last video we focused on A, H, and K and how those affect the parent functions. Today we're going to focus on C, okay, and how that changes my graph. So looking at our first example, first thing I want to identify is what parent function is this? So I see a cube at the top, so this is a cubic function. We have x cubed, which has this generic shape, right? So let's start by figuring out all of my different possible transformations. Okay, so I look through the problem. I don't have A. C is 2. Now remember, on the inside we always do the opposite. So instead of doing 2 times, right, I would really be dividing by 2. So the easier way to do that instead of dividing everything is think about multiplying by its fraction, okay? So I'm going to take all my x values and I'm going to multiply by 1/2. Now, I look through the problem still. I have no h and no k. So the only shift that I'm going to have to deal with is this c value and it changing my x's. So with cubic functions, we had our main points. Okay. Now I want to multiply all my x's by 1/2. So -1 times 1/2 would give me -1/2. 0 times 1/2 would give me 0, and then 1 times 1/2 would give me +1/2. Now, before we graph our transformation, I first want to put our parent function on the graph. So plotting those 3 main points, 0, 0, 1, 1, -1, -1. So I have this graph. Okay, so there's my parent function. Now, I want to graph that transformation. So plotting my new points, I still have 0, 0. But this time I'm going to have 1/2, 1, and -1/2, 1. So my new graph is being compressed horizontally. Right? So real quick, just explaining how C affects my graph. When I'm multiplying that fraction, right, it's going to compress my parent function in, okay? Now, if it was a fraction as a C value, I'd multiply by its reciprocal. So like say it was 1/3 on the inside, I'd multiply by 3 and that would expand me out horizontally, okay? So my domain and range, remember for cubics here, domain is going to be all real numbers and my range is also all real numbers since I don't miss anything, okay? Now, each problem we're going to look at today is going to increase in difficulty, so we're going to start introducing more and more of the shifts along with C. So here is my next problem. Now, again, first thing I want to identify, what function do I have here? So in this case, I have a cube root of x, which looks like this, right? Now, before I can identify my shifts, I have to change the inside. And if you notice, that's not quite our function notation, right? We want to keep it as a f of c x minus h plus k. So whenever you have a c value and an h value, right, we have to factor out that c to get it out front, kind of unattached to the x a little bit. So to change this problem, I would factor out 1/2. So my new problem would become 1/2 parentheses x. Now, I'm taking 1/2 out. So if you think about distributing 1/2, what would I have to multiply 1/2 by to get 4? So in that case, it would be 8. Okay, so there's my new function with that c value separated from everything inside. Now I want to identify all my shifts. ACHK. So I have no A. C is 1/2, which means I'm going to multiply my x by its reciprocal. So I'm going to do 2 times all my x values. Okay. Now, H on the inside, always the opposite, right? So if it shows me +8, that really means I'm doing -8. So I'm moving left. And there's nothing at the end there, so there's no K value. Now, let's set up our table of values. So again, cube and cube root, I really just care about those 3 main points. -1, -1, 0, 0, 1, 1. So let's graph that parent function real quick. Do purple. So 0, 0, 1, 1, -1, -1. And I have this basic shape, okay? Now, let's go through and multiply all of my x values by 2. So -1 times 2 gives me -2. 0 times 2 would give me 0. And then 1 times 2 would give me 2. Now, I'm going to do this in 2 steps. So I'm first just going to graph the C, okay, and how that affects my graph. So I have 0, 0, -2, 1, and 2, 1. So see how it pulled my graph left and right? So it has that horizontal stretch on this one. So again, I'm going to use a dotted line because we're not done yet. So now my graph would be like this. Okay. Final step, we're going to shift everything left 8. So starting with 0, 0, I'm going to go left 8. 1, 2, 3, 4, 5, 6, 7, 8. Which would put this point here and this point here. And now I can draw my final answer. Okay. So again, domain and range for cubic, or cube root, sorry. I still have all reals and all reals. All right, let's keep going. Let's look at number 3. So again, I look on the inside, I see that I have a C value, but it's attached to X, and I have an H. So I need to change this inside. So in this one, I'm going to factor out a 2. So I would have Y equals absolute value of 2, X minus 3. And then the plus 1. So again, A, H, A, C, H, K. No A value. C would be 2. So I'm going to multiply all of my x's by 1/2. H would be positive 3, right? Always the opposite. So that's going to shift me right. And then K would be 1. So I'm going to go up 1. Now, to just get my table real quick of the parent function, I would have -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. All right. So again, first thing I want to take care of is my C value. So I'm going to multiply all my x values by 1/2. So -2 would become -1. -1 would be -1/2. 0 would stay as 0. 1 would be 1/2. And then 2 would be 1. So we can just jump right into graphing this. So I have 0, 0, 1/2, 1. -1, 2, -1/2, -1, -1, 2. again, I'm going to do a dotted line because I still have to shift it right and up. Okay, so final step, I'm going to shift all of this right 3 and up 1. So right 3, 1, 2, 3, and up 1. So that puts my new vertex or middle point there. Doing the shifts to the other points, that would move this one here and then here. So my final graph would look like this. So my domain would be all real numbers, and my range would be from 1 to infinity, or y is greater than or equal to 1. Okay. Keep going here. All right, so this introduces a little bit of everything, okay? So again, look at your inside. I see that I'm gonna have to change the way that looks. So we'll do that first. So I would have y equals -3 square root. I'm gonna take the 1/2 out. So I would have x, and then I wanna think about what times 1/2 would equal 1, and that would be 2. And then I have plus 2. So I want to identify all of my shifts. So we have a equals -3, c equals 1/2, h equals -2. So I'm going to go left, and then k is going to equal 2. So it's going to take me up. Now, my table of values, don't have a ton of room here, but remember for square root we had 0, 0, 1, 1, 4, 2. So I'm going to multiply my x values by 2, right? Because c is 1/2. So that means I'm going to have x times 2. And I'm going to multiply my y's by -3. So I would get 0, 2, and 8. And then my y's would become 0, -3, and -6. So let's just plot those new points. So I still have 0, 0, 2, -3, and then 8, -6. So that puts me here. Okay. Now, I'm going to go to the other graph to do my left and right shift. Okay? So instead of at 0, 0, I'm going to go left 2 and up 2. So that puts my new starting point right there. Now instead of 2, -3, right here, right, we're going to go left 2, up 2, which puts that here. And then instead of 8, -6, we're going to go left 2, up 2. So here would be my final answer. All right, so my domain would be from -2 to infinity, or x is greater than or equal to -2. Now my y, I'm going from bottom to top. So this would be from -infinity to +2, or y is less than or equal to 2. Okay? Now let's look at one more of those that contains everything, right? So I have a quadratic, and I notice the inside I'm going to have to change. Okay? So changing that thing first, I would get y equals 2. I'm going to take out the negative 2. So I would have x plus 2 squared, and then minus 3 at the end. So listing out all of my transformations, I have a equals 2, c equals negative 2, h equals negative 2, right, the opposite of what's shown. So I'm going to go left on that. And then k is negative 3, so I'm going to go down. Now, writing out my table, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Now, I'm going to multiply all my y's by 2. I'm going to multiply all my x's by negative 1/2. So I would get positive 1, positive 1/2, 0, negative 1/2, and negative 1. For the y's, I would have 8, 2, 0, 2, 8. Okay, so graphing that, I have 0, 0, half, 2, and then 1, 8. Same thing on the other side. Now, the thing to note with this, since quadratics are symmetrical about the y-axis, right? That negative on my c value would normally flip me around that axis, right? So think about spinning your graph horizontally, right? Left to right. But since quadratics are symmetrical, when I spin it, it's going to look the same, right? So if you notice, when we did our multiplying, it just changed where the negatives and positives were located. It flipped those things around, but the numbers are still the same. So in this problem, that horizontal flip from the negative c was unnoticed because of that symmetry, okay? Now, the last step is to take care of my h and k. So I'm going to move everything left 2 and down 3. And I'll just do it all on the same graph here for you. So I'm going to take 0, 0 and go left 2, down 3. Puts that there. Left 2, down 3, and here. And then basing it off of that symmetry, I would be here and here. So here would be my final product. Okay, so the domain is going to be all reals. My range, bottom to top, so I'm going from negative 3 to infinity. Or y is greater than or equal to negative 3. All right, so that kind of covers handling the parent functions with a c value. But now we're going to talk about my integer function, okay, and how we handle a and c in the problem. So if you remember from last video, I kind of talked about what a and c does to the integer function. So remember that a represents the distance between each step, so how far I have to jump up or down, okay? And then the c value, right, represents the length of each step, okay? And again, when it's on the inside, you think about the reciprocal. So a C, H, K. A would be 3. So that means the distance between each jump is going to be 3. And C is 1/2, which means that I'm going to have a length of 2. Right, the reciprocal of 1/2 is 2/1. I have no H and no K. So I'm going to do all of this graphing kind of together here. Now, I usually start at 0, 0. That's still the case because I'm not shifting left or right or up or down, okay? Now, instead of a length of 1 and then my open dot, I'm going to have a length of 2 and then my open dot, okay? Now, to get to the next step, I have to go up 3, right? The distance between my steps is that A value, so 3. So I'm going to go up 3 and put my closed dot. And then I'm just going to keep repeating this process as much as I can. So I have a length of 2, open dot. Jump up 3, put my closed dot, length of 2, open dot. 1, 2, 3, closed dot, length of 2, open dot. Now, I got to do this in the opposite direction as well. So down 3, this time closed dot, still a length of 2, open dot. 2, 3, 2, closed dot. 1, 2, 3, closed dot. And I can't go any further. So my domain, again, for integer function or step function, I don't miss any x values. So my domain is still going to remain as all real numbers. Now, I need to think about what my range is. So if I think about my y values, I have 0, 3, 6, 9. And then the negatives too, -3, -6, -9, on and on and on. So it seems like it's all of my multiples of 3. So the way we write that is I have my integers, right? But I only want the multiples of 3. So I would just put that in front. So 3 times z. Okay? Last problem here. Let's look at an integer function with everything. Okay? So I start by looking at the inside, right? And I need to change that. So my function, -2, I got to take the 1/3 out front. So that would be -3 plus 1. So listing out all of my transformations, I would have a equals -2, which would be my distance between each step. And because it's negative, I'm also going to flip. Okay. C is 1/3. So that means that my length of each step is really 3. I have h equaling +3, so we're going to go right. And then I have k equaling 1, which means we're going to go up. Now, I'm going to handle A and C first, okay? That's kind of a good tip here, and I'll write that at the end. You always kind of want to start with A and C, and then do your left, right, up, down, if there is anything. So, starting at 0, 0, right, because we're not going to shift left, right, up, down yet. I have a length of 3. So 1, 2, 3, open dot. Now, normally from here, I would do whatever my A is and go up that distance, right? But because it's negative, that means I'm flipping about my x-axis. So a vertical flip, right? Another way to think about it with step functions is that I'm going to go down 2 to my next step. So going down 2, close dot, length of 3, down 2, length of 3, down 2, 3, length of 3. So that one goes off a little bit, but it's fine. Now going in the opposite direction, 2, close, open dot, 1, 2, 3, close dot, open dot, 1, 2, 3, closed, up 2, open dot, 1, 2, 3, closed. And then my next one will be off the graph, so I won't do that one. All right. Now, my final step, and I'm going to do this on the other graph here. I want to go right 3 and up 1. Okay. So instead of at 0, 0, I'm going to go right 3 and up 1. Length of 1, 2, 3, open dot. Now, instead of doing that for every dot, I'm just going to kind of regraph it based on my A and C. So down to 1, 2, 3. Next one would be off the graph, so let's go the other way. Up 2, open dot, 1, 2, 3. Up 2, open dot, 1, 2, 3. Up 2, 1, 2, 3. Up 2, 1, 2, 3. And there's my answer. So again, domain, all reals. My range, so we got to look at our numbers here. We have -1, 1, 3, 5, 7, 9. So again, this is all of my odd integers. So from the last video, remember we called odd integers 2z plus 1. So that just represents my odd integers, okay? So that tip I was telling you, you might want to jot down, okay? You always want to start with A and C, okay? It'll just make things a little easier for you. So start with your A and C, then after you graph the A and C part, we'll shift based off of H and K. So then do HK. Okay? And that's it.